All right, so today we're going to talk about ellipses, and the definition of an ellipse is as written below. I'm going to draw out a diagram. So here's an ellipse. We're going to just make it have a center at the origin. And there are two foci, which are going to be along the major axis. So these are the same distance away from the center. Here's focal point 1, and here's focal point 2. And the definition of an ellipse is that any point that I select has to be the same distance from focal point 1 to focal point 2, and if I add those up, that distance stays constant. So if I pick a point here, it has to be the same distance if I add those distances together. And if you start plotting them out, that's how you get your ellipse. Okay, so here's your ellipse. That's why in that demonstration video that you watched earlier, if you take a string and then these are your two focal points, this distance doesn't change, because this is, let's say this is point P. This is the distance from focal point 1 to P, and this is the distance from focal point 2 to P. And if I add those together, that's always going to be constant. Now that distance is always going to be equal to 2a, which is the length of the major axis. All right, so a couple generic equations for an ellipse that you should know is it doesn't always have to start at the origin. The center can be anywhere, so it can be shifted left or right or shifted up or down. And it's always going to be equal to 1, so if this is not equal to 1, you're going to divide so that you have numbers on the bottom here. And your major axis is going to be whichever of these two numbers is longer. So your major axis could be along the horizontal or it could be along the vertical. All right, so your center is at HK. Could be at the origin, it might not be. All right, length of the major axis is 2a. The length of the minor axis is the shorter of the two, so that would be 2b. Sometimes they refer to like half of the major axis as like semi-major axis, so semi-minor axis could be half of that. The eccentricity is always going to be C over A. Now in an ellipse, C squared is equal to A squared minus B squared. So if you solve for C, this could also be written as the square root of A squared minus B squared over A. The eccentricity should always be between 0 and 1. If it's exactly 0, then that's going to be a circle, which is an ellipse. Kind of like how a rectangle is a square. No, a square is a rectangle, right? All right, so a couple other things. The foci, there's two of them, are located along the major axis. And this letter C, that's how far away they are from the center. So they're either going to be plus or minus C units from the center. All right, and another point that you need to know are the endpoints of the major axis. These are called your vertices. Actually, this would be like vertex 1 and vertex 2. All right, so we're going to do a few examples. They're going to be on page 851, and it's number 1, 10, 19, 21, 25, 27, and 29. All right, so some of the questions just ask you to graph. Some of them will ask you to just identify like where the focal points are, the center, the vertices. It just all depends on the problem. All right, so make sure that you read the directions. It'll be different for pretty much every problem. All right, so in number 1, it says that you're given this equation, 4x squared plus 9y squared equals 36. And they want you to specify the length of the major and minor axes, where the foci are located, and what is the eccentricity. Okay, so first off, we need to make sure that we have this in the correct form. So for an ellipse, we want it to be equal to 1. Therefore, we need to divide everything by 36. So we have 4x squared over 36 plus 9y squared over 36 equals 1. And then just reduce. So you got x squared over 9 plus y squared over 4. Now, if it helps you, this is 9 is a squared. So a is really 3, and the major axis is 2a. So 2a is 6. You don't have to show all that work, but the length of the major axis is 6. The minor axis is going to be related to b. So b is equal to 2, and 2b is equal to 4. All right, so if you draw it out, it's kind of easier to come up with the foci that way. I know it's not shifted left, right, up, or down, so my center is going to be at 0, 0. I know that my major axis is going to go 3 units to the left and right, so these are my vertices. They don't actually ask you for those, but we'll label them anyway. We also need to go 2 units up and 2 units down. All right, so there's my picture of my ellipse. My foci have to be along the major axis. So I need to figure out what is C. C is equal to a squared minus b squared. So I'm just going to figure that out. So we have c squared equals 9 minus 4, which is 5. So this is going to be square root of 5. And square root of 5 is like a little more than 2. So it'll be right there. And right there. So there's my focal point 1. It doesn't really matter which one's 1 and 2. So my foci are located at, this is square root of 5, right? So it's going to be square root of 5, comma 0, and negative square root of 5, comma 0. All right, and then I think that's all it asks you for. It wants the eccentricity. All right, so that is c over a, which is root 5 over a, which is 3. And something for you to double check, right? You might want to make sure that square root of 5, that's about 2, right? Divide by 3, that should be between 0 and 1. So the closer it is to 0, the more it'll look circular. If it's closer to 1, it'll be really like long. All right, next problem is problem number 10. Alright, so problem 10 is same exact directions, except it says 9x squared plus y squared equals 4. If you want, you could pause the video and then do the whole problem and then check with my solutions. Okay, so you can start now and then start the video again when you're ready. Alright, so I'm going to divide everything by 4. I get, this is x squared over 4 ninths. This is y squared over 4, and this is 1. Right? 9 divided by 4 is the same as 1 over 4 ninths. And if I take the square root of that, this could be written as 2/3 squared, and this is 2 squared. And really, it doesn't matter if you write your equation like this or this. Okay, so it wants to know what's the length of the major axis. So that should be twice 2/3, which would be 4/3. The length of the minor axis should be twice b, which is 2 times 2, or 4. All right, my center, if I want to graph it, is at 0, 0 again. So I need to go no, I have this backwards. 4/3 is smaller, right? This is just 4. All right, so I need to go 2 units in the y direction, up and down from my center. I need to go 2/3, so a little less than 1. in the x direction, so this is a ellipse that's longer vertically, which means that my focal points are going to be somewhere along here. So if I do c squared equals a squared minus b squared, a squared is this one, 4 minus 4/9, which is 36 over 9 minus 4/9 is 32 over 9. And if I want c, I have to square root that. So this will be 4 root 2 over 3. Alright, so I'm just going to get a decimal approximation for that because that'll help me graph it. So I'm going to go about 1.88 units above and below. So there's one of my focal points. There's another focal point. Alright, so you need the major axis, the minor axis. The location of my foci are going to be 0, comma, and then it's plus or minus 4 root 2 over 3. So that's an exact value. You could do the 1.886 as your exact, or your approximate. And I believe that's all we need to find. So major, minor, foci, oh, eccentricity. I keep forgetting about that one. Alright, so that is c over a. So I need to do c is 4 root 2 over 3, and a is 2. So really I have 4 root 2 over 6, which is 2 root 2 over 3. And then if I just double check, that's 0.94. Right, so it's a long and skinny ellipse. All right, next problem is number 19. Alright, so this one is a little different. We're going to need to complete the square. So it's 3x squared plus 4y squared minus 6x plus 16y plus 7 equals 0. Alright, so we also need to identify the center. Right, this one, we knew the center was at 0, 0. That's pretty easy. Anytime where you complete the squared, probably you're not going to have a center at 0, 0. Alright, so I would group your x's and y's. So I would move the 3x squared minus 6x. I have my 4y squared plus 16y, and I'm going to move this 7 to the other side. So in order to complete the square, I need to divide out my GCF. So I really have x squared minus 2x, and I'm going to put in a box there. Here I'm going to take out my GCF of my y's, which is 4. So I have y squared plus 4y plus box. Alright, so to figure out what goes in here, I'm going to take half the middle term and then square it. So first do half the middle term, that's negative 2. Cut it in half, that's negative 1, and I square it, that's positive 1. Now to balance out my equation, I had 3 times 1, so I need to add 3 times 1, or in other words, 3. Here I'm going to do half my middle term, so 4 over 2 is 2, squared is 4. So I need to add 4 times 4, which is 16. So negative 7 plus 3 is negative 4, plus 16 is 12. And then I'm going to factor this here. So factoring this, I get x minus 1 squared. Factoring the y's, I get y plus 2 squared. And then we almost have our ellipse equation, except this should equal 1, so I just need to divide everything by 12. If you're lucky, these come out to be nice fractions. So that's 1/4. This is 1/3. And this is 1. All right, so there's my ellipse. My center is now shifted over. It's at 1, negative 2. So when I graph it, I'm going to start here. All right, so which one of these is bigger? This is going to be related to my major axis. So a squared is equal to 4, and a is 2. B squared is 3, so b is root 3. All right, so my major axis is twice that length, so that's 4. My minor axis is twice this length, so that's 2 root 3. So this tells me I need to go in the x direction. I need to go 2 units to the right, 2 units to the left. And in this direction, I need to go root 3. So if I take the square root of 3, I get 1.7. So I need to go 1.7 up and 1.7 down. So it's almost circular, because right, we're going 1.7 up and down as opposed to 2 left and right. We also need our foci, so we need to figure out c squared equals a squared minus b squared. So that would be 4 minus 3 equals 1, so c equals 1. All right, so along my major axis, which is along my horizontal, I need to go 1 unit out. All right, so my focal points, it was going to be at my center, which was 1, but then I need to go plus or minus 1, and I'm still going to stay along negative 2. So 1 plus 1 gives me 2 comma negative 2, and 1 minus 1 gives me 0 comma negative 2. Right, these are my focal points. So those are my foci. And then the last thing is your eccentricity. All right, so that is C over A. C is 1 and A is 2, so my eccentricity is a half. All right, about halfway done with our examples. Okay, so now we've got number 21. Very similar. So again, if you want to do number 21 on your own and pause the video and then double check with what I have, that would be a good way to see if you know what you're doing for completing the square. All right, so I'm going to complete the square now. If you want to pause and restart, that would be good. All right, so now I'm going to group my x's, I'm going to group my y's, move my negative 188 over, and I have to factor out my GCF. I have to factor out my GCF here. And then I need to add something on both sides so that I get a trinomial that's a perfect square trinomial. So half of negative 8 squared is negative 4 squared, which is 16. So I need to balance my equation and add 5 times 16, or 80. Here I'm going to do negative 12 over 2 is 6 squared, that's 36. So I'm going to add 3 times 36. All right, so I'm going to have 5 times x minus 4 squared plus 3 times y minus 6 squared equals, and then I need to do negative 188 plus 80 plus 3 times 36. So I get 0, which is interesting. So this is actually called a degenerate ellipse. Right? It's almost an ellipse, but it doesn't quite work out because that needs to be some kind of a number that's non-zero. So all this is really like, even if I divide by 5 and 3, I'm going to get x minus 4 squared plus y minus 6 squared divided by 5 and then 3 again. And that would give me 0. All right, so all this is a point at 4 comma 6. So an infinitely tiny ellipse, I guess, but it doesn't really count as an ellipse. All right, number 25. So this time we need to create the equation of an ellipse given that the foci are plus or minus 3 comma 0 and the vertices are plus or minus 5 comma 0, and that's all the information that they give you. Now they want you to come up with the equation in ax squared plus by squared equals c. As opposed to equaling 1, they want it to equal like a whole number. All right, so I think it's easiest if you draw it a picture. So my focal points are at 3, 0 and negative 3, 0. And my vertices are at 5, 0 and negative 5, 0. Which this tells me that my ellipse has to be like a long one to the left and right. So this is my major axis right here. So my major axis is 10, and it's exactly symmetric over the y-axis, so I know that my center has to be at 0, 0. So I know that I'm going to have x minus 0 squared, y minus 0 squared. Right? How far do I go left and right is 5 units, so this is 5 squared. I don't know how far I'm going up and down, but based on my focal points, I can do c squared equals a squared minus b squared. My major axis is 5 squared, or 10, so that's 5 squared here for a squared. I don't know b squared, but my c squared is 3 squared. So this is 9 equals 25 minus b squared, so I get b squared equals 16 and b equals 4. So this tells me that I have to go 4 up and down. If you need to draw it out, you can. I don't think that you actually need to do that. This should equal 1. Okay, so then the last thing is this is technically your standard form, but we need to get rid of my fraction. So if I multiply everything by 25, right, I'll have x minus 0 squared plus 25y minus 0 squared over 16 equals 25. And if I multiply everything by 16, right, I'm going to get 16 times x minus 0 squared plus 25y minus 0 squared equals whatever 25 times 16 is, and that's 400. Now, I don't need the x minus 0 squared, so 16x squared plus 25y squared equals 400. And there you go. All right, number 27 is very similar. All right, so they tell you that your vertices are at plus or minus 4, 0, and your eccentricity is 1 over 4. All right, so that tells me that, again, my center must be at the origin if the endpoints of my major axis are along the x-axis. So I know that I'm going to have x squared, y squared, I'm going to have a 1 always here. So I know that I have to go 4 units left and right. Right? The formula for eccentricity is E equals C over A. And I know that A is 4, so I've got E equals 1 over 4. That must mean that C is 1 and A is 4. All right, so now I know C equals 1. Based on that, I can figure out what my B value is. So C squared equals A squared minus B squared. So 1 squared equals 4 squared minus B squared. So B squared equals 16 minus 1, which is 15. All right, so B is equal to root 15. So this is going to be just 15, right? Root 15 squared is just 15. And then this technically would be okay, except I need to multiply by 16 and then by 15 to get rid of my fractions. So this is going to become 15x squared plus 16y squared, and whatever 16 times 15 is, that's 240. Equals 240. A lot of times we're not going to ask you for answers like this, but maybe on a multiple choice they would have that listed as your options. All right, last problem, and then I believe we are all done. All right, so this one tells you that your focal points are at 0, 2 and 0, negative 2. It says the endpoints of the major axis are at 0, plus or minus 5. So a lot of times for these, I would suggest that you just draw a picture. All right, so I know my 0 plus 2, negative 2, those are my focal points. And I need to go down 5 and up 5. So my ellipse is going to look like elongated vertically. Right, so that tells me that, again, my center is at the origin, because these are exactly symmetric, or same distance away from the origin. I know that my y has to be the bigger one, so this one's going to be the 5 squared. My focal points tell me my c value, which is 2. So I'm going to use my c squared equals a squared minus b squared equation, and I know that 2 squared equals 5 squared minus b squared. So b squared is equal to 25 minus 4, which is 21. So b is equal to root 21. And then root 21 squared is 21. So this answer would be fine, except they don't want it to be in that format. They want you to get rid of your fractions. So I'm going to multiply by 21 and then again by 25. So if I multiply that, this will become 25x squared plus 21y squared, and then whatever 21 times 25 is. So that's 525. Okay, and then we are all done. So if you have any questions, write them down and then ask about them when you get to class tomorrow.